Okay, back to the hand-wired Tram D201. Pretty much finished up the underside here. So, all the electrolytic capacitors and all 1, 2, and 3 watt resistors have been replaced. Like I said in the previous now 2 videos, the initial fault was this resistor had burned up. If you remember, was pretty much charcoal burned in half, and then this one down here and back here were also burned up and due to fail at any day. And like I had said, the actual cause of that is this large resistor. It was originally a 3 watt resistor, dissipates a lot of heat, and heat soaks the other resistors that are above it, and then they just end up overheating and burning up. So both of the 47,000 ohm 3 watt resistors have been replaced with now 7 watt. We can get down here and see that, but they're 7 watt. These are actually a little bit older stock. I got a bunch of these, and I like these because they're really long. So, you know, the original 3 watt was about, from the end here, about that long. So it adds all this extra length, lots of room to dissipate heat over a lot wider area, and then they're also raised up higher, so there's a lot more air space around them to cool, you know, to keep everything cool so it doesn't overheat. But like I say, all the electrolytics, the radials, and all of the axials, everything's been replaced. Had taken that jumper wire that was here out, had replaced this resistor because someone had chopped the leads off and done a really bad job soldering it back in. And one thing I had told you should always do in anything tube type, even if they don't have them, it's something you should add, are your safety bypass caps. Now, here's all of the original parts. Here is the original safety bypass capacitor. You see it's a dual element, so it actually, instead of like most of your ceramic capacitors normally have 2 leads, this actually has 3 because it's a 2 element capacitor. So it's been replaced with modern, now these are, I don't know if I'll even be able to get zoomed in to where you can read this small ones, but these are X1Y2 safety rated disc capacitors, and these are your line, because they go from line to ground. So replace the dual element with 2 safety rated line to ground capacitors, and then here, actually you can read it on this one, this is an X2 rated safety capacitor, and X2 capacitors are rated for across the line. So that will, like I say, they're safety caps, and then also they can help to eliminate some hum and buzz noises and whatnot in radios. So even if your radio doesn't have, if your work is older radios might not have had especially this one, though usually pretty much everything always had your lines to ground, but if they have, don't have, doesn't matter. Always, if they don't have them, add them. If they have them, and they're original, replace them. Because like I say, these parts are the hardest working parts in anything electronic. Be it your television, piece of test equipment, your radio. If it plugs into a wall, this is on 100% of the time that it's plugged into an outlet. Because this is before the power switch. So they're right off of the power lines, so they're on all the time. They catch every surge, spike, every bit of noise, anything that comes in through the power line goes through these capacitors. So like I say, they lead a hard life, and that's why a lot of these things you'll see, especially in the trams this style, they'll be blown out just from decades of abuse from the power line. So there's pretty much the finished underside. I'll get her flipped back over, get the, of course, you've probably noticed the big hole here. I'll get the board reinstalled on the other side. Remove the channel selector crystal control board out to clean all the contacts on the rotary switch. Get that put back in. Put all the tubes back in, which is something you should always do anytime you're doing any soldering down here. Always recommend removing the tubes. So when you're soldering, like, you know, this resistor here is soldered directly to a pin on the tube socket. So I always what I do is, matter of fact, flip around here, you can see it sitting down here on the floor. You can see there's I just take pieces of foam, cut out, and that's where everything gets stuck. Then I test them, take the the boards out, the relays, all the tubes, test everything, and then when I'm done, I'll put everything back in. But so I'll get her all put back together, get the alignment done. Oh, one other thing I wanted to tell, because I had some people ask me before, there's 2 fuses in this radio. Actually, there's 3, but they'll say there's a fuse that no one can ever seem to find. You'll have, this is your main line fuse. There's another fuse on the other side here, mounted right about here on the top side. But there's one fuse no one can ever seem to find, and that's the fuse for the filament circuit, or the heater circuit for all of the vacuum tubes. Well, it's not your standard looking fuse, it's actually just a piece of wire. So if for some reason you ever turn your radio on and none of the tube filaments light, they're all dark, and you check your main fuse here, check your main fuses, and they're fine, odds are it's this little piece of wire right here. See it in a piece of clear insulation. That's actually the fuse. If you notice, here's your transformer right here, and you'll see off of this fuse, get the camera right, okay, you come across, goes to this green wire, comes into the transformer, okay, and then the other green wire you'll see comes over to the first tube, and then these brown wires branch off to every other tube in the radio. So that's the voltage, the AC voltage. It's not rectified. That's the AC voltage for the filaments, what makes the tubes glow. So this is the piece of wire here, which is a fuse. It's just a fuse link. Instead of using a fuse, it's a fuse link wire. So if it ever burns up, your tube filaments won't light. So that would be the piece of wire to check. Just make sure if it burns up, always use the same gauge wire. If you use a heavier gauge wire, the odds are, if you have a problem, dead short in your filament circuit somewhere, you stand a better chance of burning up your transformer, which you don't want to do. It's just like your main fuses. Don't ever use a larger fuse. If the fuse blows, it blew for a reason. There's a problem. It was overloaded. You go sticking a larger fuse, or in this case, a larger piece of fuse link wire into your circuit, and that high current draw, overload, a short circuit, whatever the problem is still there. You end up with the possibility of doing some serious damage to your radio, burning up other components, burning your transformer up. So be sure you always use the proper size fuse, or like I say, in the case for the filament here, use a piece of the proper gauge wire for the fuse link wire there. So just a little tip to keep you from turning your radio into a smoke bomb. Because once you let the magic smoke out, it's really hard to put back in.